Hi friends, welcome to today's lecture, that is data structures and algorithms. In the last video, I have discussed what is data and data structure and where the data structure is stored in the memory. From that point of view, I can define today what is a data structure. Data structure is a representation of data in a system's memory is called a data structure. It is also a systematic and programmatic way to organize data in order to use it efficiently. Almost all applications uses various types of data structures in any one or another way. Then coming to why we need the data structure and algorithms. There are three common problems that any applications face day to day. That is data search, processor speed and multiple requests. To store a billions of data items in a memory, for example, if an application is to search a data in an item, then as we search a data, the data grows up and the search will become very slow. Then coming to processor speed, although it is very high and it may falls limited if the data grows to a millions of records. Then multiple requests. Thousands of users can search a data simultaneously on a web server. Even the server is very fast, it may fail while searching the data. Then coming to what are the applications of the data structure, and that is algorithms. Algorithm is a step-by-step procedure which defines a set of instructions to be executed in order to get the desired output. Then coming to the characteristics of an algorithm. Algorithm have the following characteristics, that is unambiguous, means it should be very clear and unambiguous. Each of its steps should be very clear and their input output should be very clear and must lead to only one meaning it should have. What is then input? The proper input may have, that is 0 or more than one input can be defined in the algorithm. Then what is an output? Output should have one or more well-defined outputs and should match the desired output. Finiteness. Algorithm must terminate after a finite number of steps. Then feasibility. It should be feasible with the application resources that are available. Independent. An algorithm should have step-by-step directions which should be independent of any programming code. So those are the characteristics of an algorithm. From that, the data structure point of view, the following some important categories of algorithm. Each and every algorithm should have these following, that is steps, that is search, sort, insert, update and delete, that is important features. That is, in coming to search, means if you want to search any data from a list of n elements, then you can use it, that is a search algorithm. Sorting, sort an item in a certain order, means either in ascending or descending order you can use. Then insert is used whenever you want to insert any data to the data structure, then insert method is used. Then you want to update an existing list to the data structure, then you are using update method. Then you want to delete any unwanted data from the list, then you can use, that is a delete data structure. So the same algorithm, these methods or these techniques you can use it for the implementation purpose also, that you can study in the data structure later. Then the following most important terms that you should follow, that is while studying, that is a data structure. Then coming to that, what is the interface? Each data structure has an interface that represents set of operations that a data structure supports. An interface only provides the list of supported operations, type of parameters they can accept, and return type of these operations in the interface. Then coming to implementation, it provides the internal representation of data structure and also provides the definition of algorithm used in the operations of the data structure. So these two are the important terms that we should follow while creating, that is a data structure. Then coming to the characteristics of data structure, that is correctness. Data structure implementation should be implemented using its proper interface, that is very correctly. Then time complexity. Running time or execution time of the operation of the data structure must be as small as possible. Then coming to space complexity. Memory usage of the data structure and its operation should be very small as possible. Then coming to its execution time. During execution of the data structure implementation, what methods or what cases you can follow? Those are the main important three cases, that is worst case, average case and best case. In the worst case scenario, where the particular data structure operation can takes a maximum time it takes, for example searching an element till end of the list you are searching, then it goes with the worst case. Means each element you should search from a large set of, that is a list. So then it takes lot of time. For such data structure we are defining, that is a worst case execution time. So that is operation case time is f of n times, then the operation will not take more than f of n time, where it represents the function of n. Then average case. This is the scenario depicting the average execution of the operation of the data structure. Then operation takes f of n times in the execution. That is the normal any execution. We can define it as an average case. That is m into f of n times. So that you can define it as a average case. Then coming to best case. In this scenario depicting the least possible execution time of an operation of the data structure. If an operation takes f of n times in the execution, then the actual operation may take time as the random number, which would be maximum as f of n times. Means whenever you go for defining any such data structure like linear search, in that you are dividing the data structure list into two. So here by dividing two you can get, that is a very easy to search the element. So that example also you can see in the later videos. So now we'll conclude this video, and thanks for watching this video.